In this video, we're going to look at changing from exponential to radicals. All right. The first thing I suggest you do is kind of separate all of your pieces. So we have 8. We have t to the 4/3. We have w to the 2/3. Okay. If your number or any piece is not raised to an exponent, it's going to go outside of the radical. All right. So and the square root of 1 is 1. So again, I have another radical here. Your denominator tells you what sits on the shelf, or is your index. Your base goes inside. And your numerator is what that base is raised to. So for w, again, denominator sits on the shelf. Base goes inside the radical. Then my exponent. All right. Then you can kind of start simplifying these. Well, 8 times square root of 1 is just 8. T to the 4th. Now, if this exponent is bigger, we're going to be able to pull out some stuff. How much stuff we're going to be able to pull out, we don't know yet. Well, there is a way you can know. I'm not going to tell you a trick because you may get confused with it. Now remember, t to the 4th means there's just 4 t's. 3 tells you how many must be in a group to be circled. So 3. So I have 1, 2, 3. So these 3 are going to get circled. And that's one group that's been brought out. So this will be one group of t's has been brought out, raised to the 3rd, or okay. Now w squared w, I must have 3. I have 1, 2. I don't have enough. If you don't have enough, you can't make a group. Okay. So that's just going to stay inside the radical. All right. From there, you just put all of this stuff together. If your exponents have the same denominator, more times than not, they will. So we're going to have 8 times t cube root of t times the cube root of w squared. And this goes back to like terms. So I'll have a t outside. I have 2 cube roots, so I'm going to simplify to make it 1 cube root of t w squared. All right. So I'll do a couple more examples. S to the 2/5. Again, S. So I make my radical. My index goes here. And then last but not least, my exponent goes up to the top. I'm then going to expand all of this, or what's inside the radical. So 5 as the index, and then S. I don't have at least 5 S's, so it's just going to be 5 and then S squared. Again, because we're changing forms, we can use Desmos to double check our work. I'm going to say y equals S raised to, I see division, 2 over 5, and I get a graph. And then I'll have y equals functions, miscellaneous, 5 S squared. And if you look, right, the graphs overlap. Again, for number 2, I can start me a radical. I see my number is raised to an exponent, so it's going to go inside the radical. Also, what's interesting is that both of these exponents have the same value, or the denominators of the exponent, is 2. So I have 3 cubed, x to the 9th. Then I just expand everything. 3 cubed is 3 times 3 times 3. X to the 9th is 9 x's. Right? And then I just start making groups. I need 2 3s. I don't have another set of 3s. I have 1 group of x's, 2 groups of x's, 3 groups of x's, 4 groups of x's. From here, I don't have any extras. So I'm going to multiply everything that I bring out. So I have 1 group of 3s, and then 1, 2, 3, 4 x's. Then multiply what's left inside. I have 1 3 and 1 x. This simplifies to 3 x 1 2 3 4. And again, I'm going to see if this is right by graphs overlap. Y equals three raised to division 3/2. From here, make sure you arrow to the right on Desmos until you get back to a base. X raised 2, so I'm going to hit a raised to the b power. Have a fraction, so division 9 over 2. And I get a graph. Then y equals my answer, which I think is 3x to the 4th power times the square root. Again, functions miss 2. 3x. And again, I want to see if these overlap, in which they do. All right, so something I haven't covered. There may be a time where only half of it overlaps. For this section, the test numbers I want you to use for x values will be 1, 2, and 3. All right, so if there was a mirror image, so if I put a negative here, so if there's a mirror like that, whoops, it won't be like that. It'll almost look like a quadratic, okay? So it'll reflect across the y-axis, don't think it's going to let me put it here. So it did. So there it reflected across the y-axis, but it would also overlap on this right side. So if half of the graphs overlap, then you're okay. So again, I'll put a note over here. Again, you can use test points. X equals 1, 2, and 3. Remember, we have to have 3 values, or 3x values, 3 points in our table. If it gives us the same values for those, then for both equations, then that's your answer.